Hanji Palwan ki hal chal. Welcome back to another video, and this is the assignment one for the robotics course. So let's begin with finding the shortest path using the Grassfire algorithm. So how it works, we need to grow from the starting point to the goal node. I have marked the goal node as 0 and the starting point here. So let's start with firstly from the goal node. So here we will mark the adjacent nodes with the increment of 1. So for example, the goal at 0, so this would be 1 and 1. So 2 here, 2 here, 3 here, 3 here, and then likewise we go like 4, 5, 6, 7, and same ways the increment goes all the way here also. So until we reach here, it's 8, right? And these black are spaces causing the problem of backtracking that we learned in the AI course. And same thing, backtracking, and this thing is going with the breadth first search function. So now you can imagine coming here as 10, and now we have 3 nodes over here. The shortest one to reach this would be here, or we can also take this one because this is one and the same thing. We can't go 12, 13, 14, 15, 16 because these would cause an increment of 3, whereas we reach here using only 1 increment, so it's almost 13. And this is how we reach the shortest path using the Grassfire algorithm. Okay, so now I have created another program which you can see on your left of the screen, which basically depicts like how we can create this thing using a Python program using NumPy, and same procedure goes over there, and you can find the shortest path. I'll show you the output first, like how does it looks like. So these are the various outputs that I have created using this particular program. Let's take an example. So suppose this is the example, and this is the distance map, how much distance is take, and it also finds the shortest path through which we can reach the goal node. It is similar of this, but it's in a programmed way. So I'll explain my program how it works. So there are 4 or 5 functions. It's create, grassfire, short path, and main. And basically we can see that for the first function, which is create function, this basically is used to create random obstacles, which is these black paths, which is -1, and also these open goal nodes. Perfect. And the parameters are like rows, columns, and percentage. And the logic behind this is like we initialize a grid filled with 0, and then we calculate the number of obstacle based on the percentage, and then we randomly select obstacle positions, and then the set grid with the which are black ones, you can see, is basically -1 positions. So the Grassfire function in the next thing implements the Grassfire algorithm to compute the shortest distance. And we have parameters like grid, start, and goal. The grid basically tells the obstacles and open cells. Start position tells the starting position, and goal depicts this red one in the program. Okay, so it follows the logic of breadth first search, which explores all its neighbor in all the directions and repeat until the queue is empty. Then we have the function of the shortest path. So how it works, it traces back the shortest path from the start to the goal using the distance map. The parameters are grid, distance, start, and goal node. Same logic, it initializes the path and start position. If no valid neighbor is found, the loop breaks. That is where we find no path found. And the main function basically ties all the components together. It creates an 8x8 grid. Then it selects a valid start point, and ensures neither there is an obstacle of -1. If invalid, it will start again. So this is about all the concept, and this is the output we have. Thank you.